In question 10, a curve has equation y equals to f of x and is given that f dash of x is equals to 1 upon 2x plus k to the power minus 2 minus 1 plus k to the power minus 2. The curve has a minimum point at x equals to 2. We have to find f dash of double derivative of x in terms of k and x, and hence find the set of possible values of k. Now, to find the double derivative, we'll differentiate the function for f dash of x. So f double derivative of x will be minus 2 will multiply by the coefficient. So this will be minus 2 into 1 upon 2x plus k. The power will decrease by 1, so that will become a minus 3. And we also multiplied with the derivative of half x plus k, which is 1 upon 2. The derivative of 1 plus k to the power minus 2 will be a 0 as it is a constant. This 2 and this 2 will cancel out. So we can simplify the expression for f double derivative of x as minus 1 upon 2x plus k to the power minus 3. Now, as we have to find the set of possible values of k, and when it is a minimum point, so what we should know is that at minimum point, the double derivative of a function is basically greater than 0. So we'll write it as minus 1 upon 2x plus k to the power minus 3 will be greater than 0, and the value of x that we have to substitute over here is 2, so that this will become minus 1 upon 2 into 2 plus k to the power minus 3 is greater than 0. 2 and 2 will cancel out. We'll have minus 1 plus k to the power minus 3 to the power 0. Now we can bring it in the denominator and write it as minus 1 plus 1 plus k whole cube is greater than 0. So now to solve this equation, we'll first cube root both the sides. So we'll get, this will be minus 1 upon 1 plus k is greater than 0. Solving this, now to find the value of k up here, we can write it as 1 plus k to the power minus 1, and there's a negative sign, is greater than 0. And to get rid of the minus sign, we can multiply on both the sides by a minus power 1. So to make it positive, 0 to the power minus 1 will still remain a 0. So this will become minus into 1 plus k is greater than 0. So we'll get minus 1 minus k is greater than 0. Taking k on the right hand side, this will become k is less than minus 1. So the value of k will be less than minus 1. In part B, it says that it is now given that k equals to minus 3 and the minimum point is at 2, 3.5. We have to find f of x. Now to find f of x, we'll have to integrate the expression for f dash of x. So f dash of x was half x plus k, and as k is minus 3, so this will become half x minus 3 to the power minus 2 plus minus, so this is minus 1 plus k, so the value of k is minus 3, so this will be 1 plus minus 3 to the power minus 2. We can write this as f dash of x is equals to half x minus 3 to the power minus 2, and we can bring this in the denominator and write it as 1 upon minus 2 whole squared, and finally we can write it as 1 upon 2x minus 3 to the power minus 2 minus 1 upon positive 4. Now to find f dash of x, we'll have to integrate both the sides. So integrating both the sides, we'll get f dash of f of x will be equals to integrating half x minus 3 to the power minus 2. So we'll increase the power by 1. So that will become a minus 1. We'll divide it by minus 1. So we'll have a negative sign up here. And we also have to divide it by the derivative of half x minus 3, which is 1 upon 2. And integrating 1 upon 4, so that will become x upon 4 or 1 upon 4x, and we'll add a plus c. We can simplify it, so this 2 will come in the numerator, so f of x will be equals to minus 2 into 1 upon 2x minus 3 to the power minus 1 minus x upon 4 plus c. Now, as the value of x was 2 and the value of y was 3 was 1 upon 2, which is 7 upon 2, so we can write this as 7 upon 2 will be equals to, and we can bring this whole bracket in the denominator to make it a positive. So this will become minus 2 upon, so this is half into x, which is 2 minus 3 to the power 1 minus 2 upon 4 plus c. 2 and 2 will cancel out. We'll get 7 upon 2 is equals to minus 2 upon minus. So 1 minus 3 will be a minus 2 minus 1 upon 2. So we'll simplify 2 upon 4 plus c. This will cancel out. So we'll get 7 upon 2 is equals to 1 minus 1 upon 2 plus c. So 1 minus 1 upon 2 is 1 upon 2. C will be equals to 7 upon 2 minus 1 upon 2, which is equals to 6 upon 2, and C will be equals to 3. So the expression for f of x will be, we can write the final f of x will be equals to minus 2, and we can write this as a positive power, half x minus 3 minus x upon 4, and the value of c was 3, so this will be plus 3. In part C, it says find the coordinates of the other stationary points and determine its nature. Now to find, for the stationary points, we'll have to put the f dash of x as equals to 0. Now f dash of x was equals to 1 upon 2x minus, we already know the value of k, which is minus 3 to the power minus 2 minus 1 minus k. So just for confirmation, it was 1 plus k to the power minus 2. So that will become 1 plus minus 3 to the power minus 2. Substituting 0 over here, we'll get half x minus 3 to the power minus 2 is equals to minus. So this will become a minus 2 to the power minus 2. Taking it on the left hand side, this will become minus 2 to the power minus 2 is equals to half x minus 3 to the power minus 2. This will become, so minus 2 to the power minus 2, we can write it as 1 upon minus 2 whole squared, which is 1 upon 4 is equals to half x minus 3 to the power minus 2. Now to make the minus 2 power positive, we can bring it in the numerator and denominator, or we can write it as 1 upon 4 will be equals to 1 upon half x minus 3 whole squared. Now taking the square root on both the sides, so taking the square root over here and over here, we'll get, this will become plus minus 1 upon 2 is equals to 1 upon 2x minus 3. Now, when we cross multiply, we will get 1 upon 2x minus 3, and this is a plus minus sign, so this will be a plus minus 2. Finding the values of x, we'll get half x minus 3 is equals to positive 2. So this will become, 3 will go on the other side, we'll get half x equals to 5, and x will be equals to 10. So as we already had x equals to 2, so we'll not use minus 2, the value of minus 2 over here, as minus 2 plus 3 is 1 and 1 times 2 is 2. We already had that value of x. We had to find the other coordinate. So the other coordinate is 10. Now once we have this other coordinate, to find the nature, we'll substitute it into the double derivative expression. The double derivative expression was minus half x plus k to the power minus 3. So as the double derivative expression was minus half x minus k, k is minus 3 to the power minus 3. So that was a plus k. So that was a plus k, and the value of x is 10. So we'll get minus 1 upon 2 into 10. This will become a minus 3 to the power minus 3. So this will become 5. 5 minus 3 is minus 2. So minus 2 to the power minus 3. This will become a minus 8 up here. Just for confirmation, just checking, it was half x plus k to the power minus 3. This will become half x minus k. The k value was minus 3. So this will become half x minus 3. We'll get 5 minus 3 in the, okay, so 5 minus 3 is a plus 2, not a minus 2. So this will become minus 2 to the power minus 3. 2 to the power minus 3 is 1 upon 2 cube, which is a minus 1 upon 8. Now, as f double derivative of x is less than 0, or it is a negative, it means that it will be a maximum point.